chemicals. There has been an explosion in Crazy Goon Town. The people are freaking out. We don't know what to do. Hi! Run! Run! A sodium meteor has hit the lake in Crazy Goon Town and is causing chaos nationwide.
Please stay inside your houses as we don't know what to do. Stay safe, folks.
Alright, so we have suspected a couple of things, but one that we are really looking into, me and my team, is that this explosion was caused by sodium reacting with water. Yesterday's temperature was a rainy day, and there were pieces of sodium left on the ground after the Crazy Goon Town State Fair. So, we have tied this together with Gibbs free energy in order to calculate the reaction. So, Gibbs free energy is the energy associated with a chemical reaction, and it can be calculated for a reaction. So, Gibbs free energy has some rules. It must be negative, and it is at the equilibrium constant, which is 298. And Gibbs free energy is at any temperature. The equation for Gibbs free energy is delta G equals delta H minus T delta S. Alright, I'm here in my secret office and I'm about to explain the temperature change and pressure change of the reaction. So keep in mind the key term hydrogenation, the chemical reaction of hydrogen with another substance, especially with an unsaturated organic compound. So hydrogenation reactions have three components. One is hydrogen, the second one is substrate, and the third is catalysts, which are all usually required to facilitate the reaction at lower temperatures and pressures, which is what happened in our reaction. Hydrogen gas reacts with oxidizing elements. As seen here, there's a piece of sodium. When sodium metal is heated, it ignites and burns, and then hydrogen gas is released during the burning process, which if reacts strongly with oxygen. The reaction will lead to evaporation due to the temperature of the water changes and the enthalpy of the water.
What you're about to see is sodium reacting with water on a much smaller scale. Sodium wants to give its electrons to the hydrogens that are attached to the oxygen on the water molecule. This is because sodium is an alkali metal and water is a polar molecule. As you can see, this is an exothermic reaction. This is because there is more energy in making the bonds than breaking the bonds. So forming the hydrogen gas and sodium hydroxide takes more energy than breaking them apart. Here, sodium is going under oxidation, and water is going under reduction. Sodium's redox number is going from 0 to positive 1, while water is going from 1 to 0. Therefore, it is a redox reaction. You could also do a titration with hydrogen chloride to neutralize and create plain water. As shown in the previous experiment, sodium is reacting with water. As you may have noticed, the sodium floats on the surface of the water and creates a small metal ball. The sodium floats because it is less dense than water, and the heat from the exothermic reaction causes it to melt and form a silvery ball as it spins and rotates through the surface of the water. There are also other forces acting on this experiment. Water has hydrogen bonding and polar covalent bonding. Sodium itself is a metal and has metallic bonds. Sodium, when introduced to water, causes a reaction that breaks apart the water to create sodium hydroxide and hydrogen gas. Although the sparks were very few in the smaller scale reaction, the flames created were from the hydrogen gas igniting from the heat. In the smaller reaction, you can tell that the water has turned purpley pink, and that's due to the increasing basicness of the solution, because NaOH is a basic solution.